This is 1.5, day 7. I'm Mr. Bishop, and in these notes we're going to be modeling with linear functions. By just making a really simple graph, so x-axis, y-axis, and then I want two lines, line A and line B, let's say, that cross somewhere on the y-axis. So just make two lines, they cross somewhere on the y-axis here. And then one on top in quadrant 1 here, that'll be line A, and then the one on bottom, that could be line B. So if I give you potential equations for these lines, for example, one equation is f of x equals 10 plus 1/4 x. The other equation, f of x equals 10 plus 1/2 x. And these are just really general sketches of lines. But if you drew anything like this, you should be able to have an idea as to which one is which. So since they cross on the y-axis, the 10 really doesn't help us that much. The 10 would be the y-intercept here. So that's the same for both of these. We have to infer from the slope as to which line is which. So then the question becomes 1/4 as a slope or 1/2 as a slope? Which one would give us a steeper line or maybe a flatter line? When you think about a slope, this one would be up 1/4, whereas this one would be up 1/2. So it seems like the 1/4 would actually be much flatter, not quite as steep, because for every 1 you go up, you have to go over 4. So that might be, well, that's definitely a lot flatter than going up 1/2. So we can think about 1/4 as being a really flat slope. That's a smaller number than 1/2. So it's not rising as much for every time it goes over. So B definitely has to be the one with the slope of 1/4, the flatter line here, and the one that goes up above, that would have to be the steeper slope, the bigger number. That would be line A. Okay, so let's consider, you've seen these lines before. Kids oftentimes get it mixed up if they're vertical or horizontal. Let's think about if I have x equals a number. Like if I have x equals 5 or x equals 7, how do you graph those? Okay, so if you've already forgotten, when it's x equals some value, like x equals 3, that actually makes a vertical line. So let's go ahead and make a little graph of this. I'm going to go ahead and make some axes. Looks like I went up 3 on the y-axis, down 3 on the y-axis. I got tick marks here at 1 and 2 on the positive x-axis. And then I want to give you some points. Let's demonstrate this with some points. Let's start out with 2, 0. Another point, 2, -1. And 2, 2. Just as a reminder, you only need 2 points to graph a line, but you should start to be able to visualize and come up with the line that I'm referring to here. I've got 3 points in a line so far. And let's do one more. How about 2, 3? So we could definitely draw the line that goes through these points. It's a vertical line. The question is, what is the equation for this line? If you'll notice, look at the pattern. Look at the x-coordinate for all of these points. No matter what the y equals, they're on this vertical line. The x-coordinate is 2. So the equation of this line is just x equals 2. Another way to think about it, when you have to graph x equals a number, like x equals 2, you go to the x-axis, find 2, and make your vertical line right there on the x-axis. Okay, how when we have y equals a number? So if you know x equals a number gives you a vertical line, y equals a number must give you a horizontal line, right? Okay, let's try to demonstrate that. Draw your axes, and let's mark off here -4 on the x-axis, +4 on the x-axis. Looks like I went up 2 tick marks on the y, down 3 tick marks on the y. I want to do the same thing. Let's get some points on here. So 4, -3, actually -4, -3. So go back 4, down 3. There's your first point. And let's see what else. -1, -3. Maybe you already know where I'm going with this line. 0, -3. 3, negative 3, and one more for good measure, 4, negative 3. Now you've got 4 points. You can already visualize it. Let's go ahead and make that line through there. So what do you notice is the same for all of these points? The y-coordinate doesn't change, right? No matter what the x is, the y is equal to negative 3. So to make this horizontal line, if it's y equals negative 3, you go to negative 3 on the y-axis and draw your line horizontally. All right, let's go to example 1. So I'm going to start by giving you a couple different scenarios. I'm going to tell you there's a line that's parallel to y equals 4/5 x plus 1. So it's parallel to this line, and it goes through the point 2, negative 3. My question for you is, what's the equation of a line that does that? So you know a couple characteristics of it. You know it's parallel to some other line, this guy, y equals 4/5 x plus 1, and it goes through 2, negative 3. Okay, so what can we infer from this information? Parallel to this line, and it goes through that point. This information, the parallel part, that's referring to the slope of our line. If it's parallel to this, they have to be sloping at the same rate. So the slope of our line has to be 4/5. That's an important piece of information we get from this line. I don't really care about this plus 1 piece. That actually doesn't help me at all in this case. I won't cross it out, though. It's kind of sloppy. I just care about that 4/5. That's my slope. Okay, so we have our slope, and what do you know? We also have a point, 2, negative 3. Why don't we consider throwing that into point slope form, and we can have our equation. Remember, point slope form is y minus y1 equals m times x minus x1. And we just want to replace the y1, the x1, and obviously the slope. So we've got our point, we've got our slope. Let's go ahead and throw those in there. Y minus the y-coordinate, negative 3, equals the slope, 4/5, times x minus the x-coordinate, which was 2. And then we're in business. We just need to simplify that. So why don't we distribute that 4/5 through and then subtract that 3 over, since that would really be a plus 3 right there. And we should have y equals 4/5 x minus 23 over 5, if you did the math correctly. So notice our line, this one, is a lot different than that line, right? Again, the only piece of information I grabbed from that line was the slope, because I knew my line was parallel to it. But my line is actually different, right? It goes through this point. Turns out it's a different line entirely. The only piece of information I grabbed from this first part here was the slope. All right, example 2. Little different scenario. I'm going to use the perpendicular symbol here. So I want to know about a line that's perpendicular, that thing. It's easier to write not the word perpendicular sometimes. Perpendicular to the line y equals 4/5 x plus 1. And my line also goes through the point 2, negative 3. So looks kind of like example 1, except for my line's actually perpendicular to this in this case. Okay, so what does this first piece of information help me out with? If it's perpendicular to this line, y equals 4/5 x plus 1, that refers to the slope. We already know the properties for perpendicular lines. You take this slope, and it's not going to be the same, right? Perpendicular, it's like the farthest you could get from being the same. In fact, it's opposite reciprocals. So the slope for my line that I'm going to write, I know it's negative 5/4, right? Opposite means flip the sign. Reciprocal means flip the fraction. So we're going to do both of those. Now I know the slope for my line is negative 5/4. Again, I don't really care about this 1 here. The only information I got from this part right here was the slope of my line. So now we're kind of in the same boat as we were in example 1. We've got the slope. We know a point. Let's go ahead and throw it into point slope form. Use that point 2, negative 3. Let's throw it in point slope form. Make sure we get our slope correct in this case. It's negative 5/4. So then let's go ahead and do the math. Put it in slope-intercept form. That means just solve for y. So just distribute the negative 5/4. And then we're going to go ahead and add, or excuse me, I should say subtract this 3 over, since this will end up being plus a positive 3, right? So subtract that 3 over. We should be looking at y equals negative 5/4 x minus 1/2, if you did it correctly. Okay, so a couple different scenarios we just saw. The first part was just telling us about the slope of our personal line, right? Parallel means you have the same slope as whatever line they tell you about. Perpendicular, you have the opposite reciprocal slope of whatever line they tell you about. We don't care. That's the only piece of information we can get from those lines. We don't care about any of the other stuff. And then we use the given point to make our equation. Let's take a look at our last example here, example 3. So for the function, f of x equals 4x minus 2. It's a linear function, by the way. I want you to find the AROC, which means average rate of change, which is a fancy way to say slope, from x, comma, f of x, that's 1 point, to x plus h, comma, f of x plus h, that's our other point. Okay, let's don't overcomplicate this. Average rate of change, that's just slope, m equals. And then we have our 2 points. We have our 2 y values, right? So y1 or y2, however you want to put it, and x1, x2. So we have f of x plus h minus the f of x piece. So subtract the y's on top, and then just go in the same order and subtract the x's on bottom. So we have x plus h here minus the x that we have there. So if you can get this far, that's great. We have 2 points. It's the exact same slope formula. You subtract the y coordinates on top and subtract the x coordinates on bottom. Now let's simplify this a little bit, though. So instead of having it in function notation here, can't we replace something and get something else for f of x plus h? So let's use the actual formula here. So f of x plus h just means you take this function and plug in, literally, x plus h. So 4x minus 2, notice I just left it blank, because in that blank spot, I'm going to plug in x plus h. So notice I've got these color-coded too. Green box here, took care of it with this green box. And then we have minus f of x. So minus, I'm not going to use the function notation anymore. I'm going to replace this with our actual formula. F of x is 4x minus 2. I mean, if you really want to leave it blank again like last time and plug in x, go ahead. But I'm just going to write, I know f of x is equal to 4x minus 2. And on bottom, there's no function notation. We can actually just simplify. These parentheses around the x plus h aren't really helping us anymore. So we just have x plus h minus x. So you'll notice the x and the minus x, those are going to cancel. Let's go ahead and cancel the x and the minus x. And then why don't we go ahead and distribute on top? We can simplify things here. Distribute the 4 to this x and this h. And then if you did it correctly, you've got these parentheses here around this 4x minus 2 when you replace that whole function f of x in that red box there. So make sure you distribute that negative through there as well. And we should be looking at everything's over h, because those x's on the bottom canceled out. I've got 4x plus 4h minus 2, and then minus 4x plus 2. Now some stuff really cancels. Let's see, we've got the 4x's, those are gone. The 2's, those are gone. So really we just have 4h over h, better known as, after those h's cancel, just 4. So this one actually shouldn't be that surprising to you. What do? We just kind of prove generally that if you pick a point on this line and then any other point, even if it's h units away, the slope is going to be 4. Shouldn't be surprising since we say lines have a constant rate of change. So no matter where you're at, 2 points on the line, the slope is 4. We actually just proved that for all the points on the line. Really important idea for calculus. I think there's a problem similar to this on almost every assessment we do in the first semester of pre-calculus. So let's just add a little visual diagram to this example. I'm going to go ahead and copy and paste it again. Go ahead and make some axes here. And I went ahead and just marked off some on the y-axis, and that's it. So x-axis, y-axis. I went down 3 on the y-axis, up 4. Again, I'm just adding this visual diagram to example 3. So if it's 4x minus 2, this is actually pretty simple to graph, right? We would know negative 2 as the y-intercept, and then the slope would be up 4 over 1. So I'm going to try to add a line in there. -2 is the y-intercept. It's got a steep slope of 4/1. I know I didn't mark anything off on the x-axis yet, so this is still a little bit rough. And then what I want to do is not pick a specific point like 3 or 4 or 5. I want to pick a point down here and just call it x. So what happens if I plug in x? What's the output? And we know that if I pick a point x, the height of that point should be at f of x. And it looks like, maybe this one's about 3. I don't know. Maybe it's a little bit under. I just want to call it x, and then the height is f of x. So that is actually the exact coordinates of this point right here. So there's inputs x, outputs f of x for whatever point you pick. And then let's move on down the line here about, say, I don't know, h units further. So let's pick a point h units away from that original point x. So this is x plus h. Who knows? Maybe this first one was 3, and you move 2 units away, and now you're at 5, right? Just for an example. Okay, well, if that's where we're at on the x-axis, then I can kind of map out the point that would be on the line, and the height would be f of x plus h, right? That's the input, that's the height there, that's the output. So we've got x, f of x, that's the point in red, and now the point in purple, that would be x plus h, f of x plus h. So what do we really do? We have this point on the line, and we have this point on the line. And we, no matter what those 2 points are, as long as they fall on the line, we just proved with our slope f of x plus h minus f of x, right? That's actually this distance right here. So that's our rise in pink over our run, which was x plus h minus x. So it's like the pink is the rise, the run could be the purple, equals 4. And that should be kind of obvious because it's a linear line. Like, we shouldn't expect to get anything different, right? The slope would be 4. Now, you're not going to have to draw any diagrams like this. I just wanted to try to visualize it for you one time. It is a really important component for pre-calculus, and definitely one of the foundations of calculus. So we're going to get really good at these. Don't worry. That's all for these notes. I'll see you in class.